Hi, pre-calculus students. How you doing today? We are working on section 3.3, properties of logarithms. This is a review for you, but it's great to review before the SAT and other things you may have coming up. It's a short chapter, 3 to 5, and it's well worth the time. We are going to use properties of logarithms to simplify exponential and logarithmic expressions. So first of all, let's review the product property. If you have the natural log of any base, sorry, not natural, that's log. If you have log base A of u times v, meaning the solution is a product, right? Here is the base, here is the exponent, here is the solution. You can break it up into two separate logs with the same base. You'll never see different bases, with log base A of u plus log base A of v. This is called a condensed version. This is an expanded version on the right. Why would we want to do that? Because u and v separately might make an easier expression to solve, or we might be able to simplify. Where does this come from? It comes from the idea that logs are exponents, and if you have two bases being multiplied, then you add the exponents. And that's exactly what we're doing here. When you see a multiplication, we're adding the exponents. Let's take a look. Of course, because it's a property of logarithms, this works for the natural log also. As you see here, condensed, expanded, right? Let's look at an example. This log base 2 of 8 times 4 would be log base 2 of 32, which is an exponent of 5. Right? 2 to the 5th is 32. Notice that when we have the expanded version, it would expand to log base 2 of 8 plus log base 2 of 4. Log base 2 of 8 is 3. Log base 2 of 4 is 2. 2 plus 3 is 5. The quotient property then makes sense that when you have a division in the solution that you would subtract the two logs, again, condensed, expanded, right? Sometimes when we have expanded, we like to go to condensed because it might be easier to solve the problem with just one logarithm. So we have log base A of u divided by v is log base A of u minus log base A of v. Of course, this is true for the natural log. Why is this true? Because when you have bases that are the same and they're being divided, right? Being divided, you subtract the exponents. And that's what this formula, this property is saying in log version, right? Here's an example. Log base 2 is 64 divided by 4 equals log base 2 is 64 minus log base 2 of 4. So 64 divided by 4 is 16, and log base 2 of 16 is 4, right? So the left-hand side is 4. Log base 2 of 64 is 6. Minus log base 2 of 4 is 2, and 6 minus 2 again is 4. So an example showing this is true. These are examples we are going to be doing in this video. Notice when you are asked for a change of base formula, you do not need to do that on your calculator, on your computer. There's so many ways there's log base right on your calculator. So no need to use a change of base formula when they suggest it. That was what I had to do in the olden days, right? The power property, most important because we're going to use it to solve exponential equations later. If you have log base A of a solution that has its own exponent, u to the n, we can bring this n out front and multiply it by the rest of the log. This is also true for the natural log, right? The natural log of u to the n is equal to n times the natural log of u. This is considered a condensed version on the right, expanded version, condensed on the left, expanded on the right. Why is this true? Because we knew that when we had a solution raised to an exponent, like x to the m, when we had a base with an exponent raised to another, that we multiplied those exponents. And that's exactly what we're doing. Here's an exponent, the log is an exponent, and we're multiplying them. Okay. okay, when we see one power raised to another. Let's see if this is true. Log base 2 of 4 cubed. So 4 cubed is 64, and we already said log base 2 of 64 is 6, right? That is the same as if you bring the exponent out front and multiply it. It's the same as 3 times log base 2 of 4, which is 3 times 2, which is 6. Notice that if this exponent were a variable, then it's great to bring it out front and multiply it because it allows us to solve. Okay, let's try solving some problems. I'm going to try to move this a little bit, move you closer to me for the math here. Let's see. Oh, here we go. A little better, little better. Okay, number 16. Log base 7 of 4. Okay, they say use the change of base formula. There's really no need to do that. I just want to point out that if you try to write this problem in exponential form, it would have a base of 7, and this says that what is the exponent when the solution is 4? Notice that this is not going to be an exact value. In fact, you would have to get it from your calculator. They are suggesting you use a change of base formula. I am suggesting on your calculator or on your computer, it's available everywhere. If you hit the math button on your calculator, and you go down to log base, can you see that? Ooh, log base. And choose that, it actually lets you put in log base 7 of 4 right here. There we go. Oh, there we go, a little bit better. And when I hit enter, 0.712, we will go to the thousands place. Okay, on number 26, we have log of 9 divided by 300. They have asked us to simplify this expression, meaning we're going to do any math we can, right? When we have fractions, 10/8, we do any math we can. Not perfect, but we can reduce. When we have radicals, square root of 50, not perfect, there's things we can do. What can we do here? Well, I can first reduce this fraction, right? I can divide a 3 out of each. Right? Now, what about if I do see a quotient rule? So how about if I split this up? Right, using the quotient property, if I expand it. Now log base 3, this is asking me when the base is 10, what is the exponent that gets me 3? Nothing exact, so it is exact as it is. What is log of 100? That is perfect. When the base is 10, what's the exponent that gets me 100? 2. There we go. And there is our final simplified answer. What if you are asked to simplify the natural log of 6 divided by e squared? Let's try the quotient rule again. Let's try splitting it up. That would be the natural log of e minus the natural log of e squared. There we go. Oh, that's a 6. There we go. Natural, let me say that again. Natural log of 6 minus natural log of e squared. How about a little power rule here? Let's bring the 2 out front and multiply it by the rest of the expression. And we know the natural log of e is 1. And our final simplified answer, the best we can do without estimating, is the natural log of 6 minus 2. How about if we simplify log base 6 of the cube root of 6? Okay, so what would help us here, here's log base 6, is to write the cube root as a rational exponent, right? This 6 is really to the first power, and I'm taking the third root. I am going to rewrite this as 6 to the 1/3 exponent in rational exponent form instead of radical form, okay? Power rule, I will bring the 1/3 out front and multiply it by the rest of the log. And log base 6 of 6 is 6, right? 6 to the first power is 6. This is a 1, and we are left with a 1/3. Take a little break while I do some erasing. Oops. To do the rest of the exponents. Again, I tend not to shut the video off to pause it because I'm afraid I won't turn it back on. And then I'll just be talking to myself here, right? Okay. All right, how far did, what was that last one we did? What are we on? Let's take a look. Did we do number 32? We did. Number 46. Let's move on to number 46. Right here. Log base 3 of 10z. And it wants us to expand the expression. Okay, that means I see a multiplication here. So I will expand it to log base 3 of 10 using the product rule plus log base 3 of z. Literally, that's it. That's it. Number 48, still asking us to expand. The expression is log base 10 of y over 2. I see a quotient property. I'm not sure why they put the 10 on it, right? Because that would be the common log. They don't really need the 10, right? I'm not going to write it. Log of y minus log of 2. Literally, that's it. Okay. Number 68, number 68. They're asking us to condense, right? So let's take a look on 68, natural log of y plus the natural log of t. I see a product rule. I'm going to condense it to one logarithm, and I will multiply the two solutions together. There we go, 68. We have one more, number 73. Again, asking us to condense. Let's see, on 73, 1/4 log base, is it a 3 on 73? 3 of 5x. There we go. Just got to be a little careful here. This is a power rule. They're asking us to condense it so that it is written in the form of a single log. And you may be like, well, isn't it a single log? No, it's not. It's 1/4 of a log, right? They want one log, okay? Meaning power rule. I'm going to bring my 1/4 up and make it the exponent of the solution. Be a little careful here. This exponent has to be on the entire solution, not just the x, not just the variable closest to the exponent. So there is section 3.3. Hoping it's a nice review for you. Have a good day.